What's going on, people? There are people saying things in the chat. There are people saying things in the chat. And there's me drinking water not in the chat, so it's all good. Oh. Twitch automatically deletes videos after a certain amount of time. And or I just haven't done any videos in a long time or any streams. So can I zoom the code in? What if I zoom it in anymore, I won't be able to program because I won't be able to see enough lines. Don't watch on your phone, watch on a real screen. Well, now when somebody subscribes, like all these crazy things are popping up. I don't understand. I don't want any of this on my screen. I want to be able to read the chat. Why? What is happening? It's like Twitch wants to be idiocracy. This is like literally, I can't read the chat. Okay, how do I turn off like Hype Train and stuff? This is terrible. I want to program. I came here so I could program like we usually do, and now I have to like manage my stream. I have no idea. I have no idea where to find these things. Oh, there we go. Hype Train. No. No. Okay. Why is the Hype Train still going? I just turned it off. I guess there's no stopping the active Hype Train. Well, I don't really know what the Hype Train is all about. I have done my best. I've done my best to turn it off. It's like Twitch thinks everybody is 12 years old. Maybe most Twitch viewers are 12 years old. I don't actually know. But wait, I didn't say save changes. Okay. Okay. There's still no stopping an active Hype Train apparently, but yeah. Okay. We are programming things on the compiler today. we're hoping to do many things on the compiler, but yeah, for now, the thing that I'm working on will probably break things for a while. So that is what it is. Let's just get compiled and make sure that we're still running. How do I feel about other YouTube channels that archive all the Twitch VODs? They're pretty scummy. I don't like that. Okay. Even if the channels don't monetize them. Yeah, it's just gross. I don't like it. Okay. We're trying to get some work done here. The work to be done is as follows. I was doing some thread sanitizer stuff, and a lot of it was just trivial cleanup of things that didn't matter. But one thing that happened was I realized, oh, there's actually a serious race condition in the messaging that goes to the user program that tells it about the structure of the code. Or at least this is the biggest race condition. There were some smaller ones that were real that I fixed. And then after this one is fixed, I think that's most, there's probably still a couple of really small problems. But so I started last night to put in this new system that would handle this race correctly by being more strict about what data it sends to your metaprogram when. The thing is just a little bit scary because it's got quite the probability to break things. So I should just be focusing on it and not like streaming and programming, because I've started the stream and already I've been really distracted by everything happening. And I'm like, ugh, I should have just like focused on this and typed it in. The problem is it's Super Stream Sunday. So I didn't have the option to not stream. So I hope you understand the predicament there. So I'm in the middle of this thing. And so the way it works, I'll explain a little bit more. The way the whole compiler works, right, is, you know, it's a nonlinear compilation process. The code goes through in a bunch of little pieces called queues. They're maybe sometimes not that little, but they get scheduled as independent pieces through all the phases of compilation, and a piece of code will progress to the next phase when it's ready to do that, and what those conditions are depends on the situation. Getting information about itself exported to your program is one of those phases that happens to these guys. And what used to happen is we would start, so each one of these queues has like an expression, a code expression that is its main expression, and then you can recurse down from there to get to the sub-expressions. So like if you have a procedure, you'll eventually recurse and get to everything in the body of the procedure, right? Okay. The thing is, sometimes you refer to things in other queues. It's not that common, but it does happen. Well, for some types, it's very common, but in general, most pointers go into your same queue, but sometimes they go to other ones. And this system was saying, well, when a queue shows up, I'm just going to recurse down and export everything in there. And like, no, you can't do that, because if you cross to another one, and that one isn't ready yet, then, well, what do? You can't export that information. So either you have to give the user incomplete information, which I don't want to do, or you defer the sending of this thing until the other thing is ready and you can give them all the information. And so I'm doing that now, right? And so the race condition was, I was crossing before into another queue and exporting information about it while it was still being processed by, for example, type inference. And that can lead to inconsistencies. So, so we're fixing that. That is what's happening. And then after that gets fixed, this is like 5 tasks down on this long list of things that I was trying to do, just to get something done on the game. But, you know, going through and improving compiler quality is a very good thing to do. So I don't mind rat holing 5 tasks down. In this case, it's just, yeah, it's just what needs to be done. So after this is done, maybe we will, I don't have Thread Sanitizer running on Windows because I would have to make Visual Studio compile with Clang or something, and I just don't want to get into that right now. So I have it on a Linux laptop that's over somewhere in the room. And so after this is confirmed working, if we are fortunate enough to get there on SuperStream Sunday, which I sure hope we are, then we'll go back and look at what race conditions are still being reported and decide if they seem serious or if they're kind of trivial, and then we can pop back to task number 4 in the stack. So we'll see about that. Does the compiler process each input in a separate thread? No. No. Each thread handles many of these queued structs. And each queued has many, many program expressions. So each thread is sort of, well, okay, it's complicated, actually. So in the compiler, the system of the compiler works as follows. You create a thing called a workspace that's got, basically each workspace is a separate place for compiling code. So code in one workspace doesn't see code in another workspace, right? And so if you've got a meta program running, then maybe, to be clean, your meta program is in one workspace and your program you're actually building is in another one, and then they're separated from each other and can have different settings and all that good stuff, right? And if you don't do that stuff, if you just compile from the command line with like just a simple, the way you would compile a single C file, for example, then that just automatically makes a single workspace, right? So each workspace has its own thread. And then from there, it calls through this whole system of the compiler of going through parsing, type checking, bytecode generation, machine code generation, and so forth, right? Now, some of those phases are themselves threaded and other phases are not themselves threaded at this time, but hopefully will be, right? So each workspace has its own thread. That thread can call out to a bunch of different parsing threads. I think we make approximately number of CPU core number of parsing threads. So to parse, that all gets parallelized, but type checking is not. So type checking goes onto the main thread of that workspace, which does happen in parallel with other workspaces, but does not happen in parallel with itself, right? So type checking is actually a big bottleneck in the compiler right now, because it's all serial. And then bytecode generation is currently also all serial, but that's not as big of a deal because it doesn't take that long. And then machine code generation is parallelized if you're using the LLVM backend, because we did that because LLVM was really slow otherwise, and that helped. x64 is currently serial, but probably will be parallelized eventually. So, you know, that's sort of the threading story. Did I see Casey proto buffing? Well, I was on a Linux laptop yesterday, so I tried to watch Casey and I couldn't do it for a long time. And then at some point I checked again and it somehow started working because, like, I don't know, I guess the Flash plugin that I was trying to install that it seemed like didn't work, in fact, invisibly downloaded in the background over the course of like an hour and eventually installed. I don't know what happened. But I saw the very end of the stream. He was, or maybe it wasn't the very end, but he was manually changing template argument namespacing in order to get it to compile. And that was very exciting. It was kind of a self-owned by Casey because he didn't add the Python 3 path on install. No, I'm sorry. Okay. I'm going to use, I'm refraining because it's Superstream Sunday and Sunday is a very Christian game, a Christian day. I am not going to unleash a stream of profanity on you. It is not a self-own. Like, you should just be able to use somebody's software, okay? If you can't just use somebody's software, that is an own. Okay, you shouldn't have to know how to add a Python path to somewhere and whatever. Like, that doesn't make any sense. All right. People's standards are so low. It's just code. Like, just use it. Chat was screaming. I don't care, dude. Chat people, it's so easy to backseat drive. Like, if you actually let each of those people who is screaming go off and do it themselves, they each would make other stupid mistakes, okay? That's the thing that you people don't seem to understand about any of this. Like, let's put it this way. Who gets better results in programming on average, Casey or a random member of chat? Okay. So, like, this is why I don't like to stream that much too, because it gets really, honestly, chat gets really annoying. It's like when you play Escape from Tarkov and people say, you can't just run around like that. I'm like, dude. When chat is 220 people, you can expect some JavaScript hacker kitties. Yeah, but no, I mean, the people saying that stuff were in Casey's chat and this chat, so I don't know. That's pre-filtered. I just, yeah. Yeah, if you want to know why I haven't streamed in a while, that kind of thing is one reason. I'll put it that way. Although there are several reasons. It's not simple. Was the TSAN test brought on by beta users? Not really. I had been wanting to do it for a long time. And then, so I said this was like task number 5 down in the stack. Task number 4 in the stack involved changing a little bit when some things happen in the compile pipe. And when I did that, in a way that didn't seem like it would be bad, I just started having crazy race conditions and compilation failures. Like, obviously, like to the point where we couldn't compile like 60% of the time. And I was like, wait, this shouldn't really be that different. And so my conclusion was that those race conditions already were there. And I was just changing the timing of them, which, like if timing changes, you could have a race that you never see because some of the work just happens to finish before the other work starts, like 99.9999% of the time, right? But then if you change that timing, things that were logically equivalent could start blowing up, right? Because they were never actually like correct. So I was like, okay, it's time to get this working. And trying to do stuff on Linux is a pain in the butt, especially because I'm doing it on a laptop, and laptops are a pain in the butt now because they're all terrible. But managed to do some useful stuff there. And so after we finish tying down these race conditions, I will go back and do the other thing that I just mentioned and see if that makes the compiler blow up again, right? If it does, then I'm probably introducing a new race condition actually, but then I'm set up to detect that. And so, maybe we'll see what's happening. Otherwise, yeah, otherwise it'll work. Have I seen the Witness Puzzle Randomizer mod? No, I haven't. I'm not sure how that would work, honestly. I mean, it would kind of wreck the game. You would have to hard code certain puzzles not to randomize. Otherwise, the game would probably be unfinishable. And then you would destroy all the ideas behind a lot of the puzzles. But if you just wanted replay value, then maybe that's fine. All right. Self-hosting doesn't matter. It's a distraction. Don't bother thinking about it. Okay. So I started doing this thing where if we try to cross a queued boundary, then we put something into a deferral list. And then, well, to turn this on, okay, let's just make sure we can still compile things. All right, great. To turn this on, oh, by the way, our compile time went up to 1.4 seconds, not because our compile time went up, but because the linker now takes 0.6 seconds. And the reason the linker now takes 0.6 seconds is we're linking in this frickin' WWise sound engine, which is giant. And that just takes a long time. So that makes me sad. But we're only taking, 0.8 seconds. And even that would be faster if we weren't streaming. And I haven't actually optimized the compiler in a long time. So, yeah. Okay. I would like to make a request. Okay, it's Super Stream Sunday, but I would like to make a request of don't ask too many silly, sarcastic questions, because it pulls my attention over to the chat every time. And like, I want to program and think about the problem today. So like on-topic questions would be great. But we want this to be a programming stream. And if I can program and read chat, then that's good. If I have to ignore chat in order to program, then, that's less good. It's probably fine. I mean, I can still stream programming, but, Do you have a reproducible way to reproduce your race condition? Well, the thread sanitizer, okay. I think thread sanitizer is very consistent as long as it actually instruments all your code, which in this case it is. I think. I'm not 100% sure, but I think it is. It won't necessarily be able to tell you everything about your race condition because it has a limited amount of memory and stuff, but I think it will report it accurately. All right. So let's do some things. So we want to return null here. And whoever calls do export, okay, so here's the thing. We're saying we're going to defer this, and we're going to poke the pointer back later. Okay. To poke the pointer back later, we actually need to have the pointer, right? And so this is going to be a little bit painful because this recursively calls itself and stuff, and we just have to modify all the calls to pass a pointer here instead of the thing. In fact, we can do that and then test that it still works. Yeah, let's try this. Okay. Let's not abbreviate. I don't like abbreviations. Okay. And then down here, this is going to be source expression pointer. All right. And now everybody who calls do export needs to deal. Not that one. That's a different overload. This one. It's just scary because I might be making an assumption that doesn't hold at some point. I hope not. Okay, this is fine. Shoot. This is the wrong thing that I'm passing. That's not the pointer that I need. I am not thinking with portals. The pointer that I need is not the pointer to this thing. It's the pointer to this thing. Okay. Rewind. YouTube Rewind 2019. All right. So really, yeah, we're going to make this void so we're going to assert result pointer. I think. We're going to see if there's any case in which passing that pointer is too difficult. And now every place where we return, oh, that was the only one. All right. Oh, because finish. I have this finish macro. So I have a bunch of macros here that just let me mention all the members. This is something that in our new programming language we could mostly automatically generate. But here we just do these, and each of these like copies some fields. All right. All right. So we're doing this. It's going to be a pain to change all these. All right, let's change the declaration. Okay, so now we just want to get it so that we compile again, because right now we will not compile. Can you handle being passed multiple points? That doesn't make any sense. There's no case. That's not how this works. All right. So here, the problem is this pointer is going to be the wrong type. So like maybe we'll make it a void star star, because we have this frickin' I don't know, maybe C++ lets you do that. Maybe this isn't a contravariance problem. I don't know. We'll see what happens. Okay. Like that. I feel like this is scary. Okay. That doesn't make any sense. Okay. So these macros have to change. Let's just start compiling this and see what it complains about. Whoops. We didn't change this. So of course it's going to complain about that. All right, now what? All right. Yeah. Wait, code. Come on, bro. Come on, bro. Get the number of stars correct. How hard is that? Okay. It is giving us a contravariance problem. And There is no good solution to this. So we have to manually cast it everywhere because C++ is poop. What are you going to do? What are you going to do? Types pointed to are unrelated. They are not unrelated. They are not unrelated, bro. All right. See if it complains less. I don't like doing that. It's very ugly. Don't do this at home. Oh, note pointers, not node pointers. This is a weird case because we'll see what happens. This is a weird case because we know blocks are always in our own queued, so we prefer to be lazy and not do this one, except the macros may force us to do that because the macros don't differentiate between overloads. We'll see. We'll see. Okay, wait. Why are we checking that? We already checked that above, so that is not necessary. Oh, these all use finish and not manual return, except down here. So we need to first fix all the returns, which hopefully there won't be many more of. Nope. Okay, but now, oh, I guess we already did the recursive calls too, or most of them, because most of those are in the macros too. And we did the macros. So let's look for do export explicitly. Oh, no? Okay, right. That's fine. That's a block export. Oops. Uh-oh. See, this is why I don't like putting these casts. See. If you make a mistake, you regret it. You regret it. That's a little sketch. It's a little sketch. Sketchy McSketchington. Okay, well that's maybe most of them, maybe. What? What? Oh. Same thing. Openter. Oh yes. Ah yes. Target, let's call it target result is result pointer. Target result. Now we're not actually going to do anything more. We just changed our code around. We probably broke something really horribly. But ideally, we could run this and see that it works. Why am I doing this? It's not good. Said initially that I was having issues with queues referencing other ones, but do I have cases where two queues reference each other? I doubt it. I doubt that that could happen. If that can happen, this system actually would handle it. I think. Yeah, I don't believe that there is any case in which what I am doing would fail to make progress. Because one of them, like, we're not stalling the processing of a queued when we see something it doesn't understand. We go through and do the whole thing, except only for the pointers that we don't know. And someone else pointing to us will not be pointing at those pointers because those are the pointers that are not in us, right? So anyone else referring to us would refer to things that we actually processed. So yeah, that's fine. Oh my God, we actually compiled Sokoban after all that. I'm a little bit amazed. I mean, you know, I always have to check and make sure I'm not getting trolled by the computer. That is a fresh compile. I did not expect that to work. I expected to make a stupid mistake that would crash things. Did I find a good debugger? No. I did not. I haven't looked that hard, but everyone has mostly the same answers as they had 2 years ago. The only new thing on the scene is Visual Studio Code, which I tried a little bit. It's not very good, but whatever. Whatever. All right, that's great. So I'm just going to commit that. Commit progress towards fixing the race condition in message exporter period. Boom. All right. Code clap, I couldn't even get to run my program. So okay. Well, now we attempt to use that. And the issue is there are several things that will go wrong once we start using this. So let's try to preemptively think of them. Okay, so I mentioned that this, for example, runs in its own thread, or if I didn't mention that before, it does. That's why we have a race condition with it, right? It's in its own thread. The way the communication with the rest of the program works is as follows. An earlier stage in the compilation pipeline will have a bunch of these queues. I don't know, let's say it has 175 of them. And it puts all of those into one data structure and says, hey, message exporter, here's a batch of work, right? And when it does that, it does an atomic increment on a variable that describes the number of work batches that are out asynchronously, right? And why is that? Well, so message exporter is handling them, but then when message exporter, after it handles them, or after it exports them, it doesn't give them back to the main compiler. It actually gives them to the messaging system. And the messaging system sends them to anyone who's listening. And then after those are replied to, it knows the batches are complete and then decrements that variable later, right? And so the compiler knows as long as that variable is non-zero of how many of these things are out in flight being processed asynchronously, as long as that's non-zero, we're actually making progress, and we shouldn't like halt compilation. All right, because even if we think we've done all the compilation that we could do right now and we would have to report an undeclared identifier or something, well, one of these jobs is out, it's sending messages. You know, the metaprogram might respond to those messages by defining some new code and adding it to the program or whatever, right? So that's how we know that might not be happening. The problem is that now when we turn this system on, the idea of batches is not going to be well formed anymore, because if some guys are in a batch but they're not ready to be fully exported, we're going to hold them back from the batch. Well, we can't really create new batches, and we shouldn't ever need to, because or we could create new batches if we tried hard enough, but we shouldn't need to, because you would only ever end up being able to complete one of these exports when new information came in anyway. So you could just add it to that batch, to the next batch or whatever, right? The problem comes in where some batches might just end up empty. And you don't really want to send like an empty batch to the source program and all that. So what I'm thinking is, instead of counting the number of batches that are alive, right, we can count the number of queues instead. So instead of each batch being 1, it would be 175, or however many are in the queues, right? So that's one change we can make, is to change the way that counter works, and hope that we don't break something there. Okay. That's all fine, but I just thought of a potential problem, and then I just forgot it while I was explaining. Oh. I mean, what happens if we make a bug in this system and we don't end up flushing everything? What I was thinking before was, you know, when compilation finishes, then at the end, we would report an error. We would say, hey, we exported some things, and those things didn't complete. The problem is that now if we change the way this counter works, we won't ever finish compilation in that case. So maybe we have to have some more accounting of, like, we could have a separate variable for the number of these that are waiting, so they don't count as in flight, I guess. That kind of makes sense to me. Well, we have a thing here. You know what? We actually have atomic read now. Okay. So here we're saying we're not going to, so normally we would be like, okay, let's decrement running and increment completed. This is sort of a race condition here, except that we don't use completed for anything. So it's fine. This is just like a debugging variable. Probably should name it that. But you know, we kind of send the message to the interceptors, and then when the message comes back from the interceptors, then we do this. But we could do this here and say like, well, you know, we're going to subtract the number of things that we actually we have to sort of, you know, sort of subtract the number of declarations that came in and add the number of declarations that are going out. But of course, you want to do that in one atomic math operation instead of two, because two is a race again, right? So that's all fine. I think that'll be manageable. Okay, I need to make some to-dos. To-do, oh, we can't put them up here because Visual Studio is poop. All right, to-do. Switch, what is it called? We're going to switch that to count queues and not batches. And make it not count deferred queues. Report error if deferred queues are hanging around. Report an error. Are there any questions about what's going on? Not general, what's he doing, because I just showed up in the stream questions, but on topic questions about the technical task that we are attempting to solve. No. Bueller. Bueller. You kind of do not understand the relationship between batches. A batch is just a number of queues all put together. And the reason is just because if you want to be fast, you don't really pass one thing at a time. If you have 175 things, and that's a low number, really we might be compiling 100,000 things, right? If you have 100,000 things, you don't want to grab a mutex and give them to another thread one at a time, because that's kind of stupid. If you have a bunch of them ready, if you have 175 of them ready, then just give 175 to the other thread, right? That's all. That's all that is. On topic questions? Nope. Okay. Well, nobody understands what we're doing. That's fine. That's fine. It's Super Stream Sunday. We have to stream even though nobody understands what we're doing. I said something about a race condition with async actions running. What was that about? Well, okay. If you're going to do operations on an atomic variable, right? If you're going to do math on an atomic variable, like add one number and subtract another number, you can't just do those as separate operations, because there's a tiny window after the first operation but before the second operation when another thread might see the intermediate value of that variable, and that's not good. That means your program is wrong, right? So you just want to compute the new value and then set the new value to the thing, right? That's all. Can you write a metaprogram to detect where multiple threads touch the same data? No, I mean, metaprograms are for compile time things, and threads touching the same data is a runtime thing. I mean, you could like sort of go full Rust and try to prove your program's correctness statically, but that is very, very limiting, and it'll prevent you from doing most useful things. So really you want something more like Thread Sanitizer to do that. So there is an issue of compiling never ending. The issue of the compiling never ending would be if we just never decremented that number all the way to 0 because we were holding on to some deferred queues that weren't ready, and then they never became ready for some reason, which there might actually be a quasi-legitimate reason for that to happen. If there is, we will have to fix it. Yeah, I don't know. We'll see. What are my thoughts on coroutines? I don't have thoughts on coroutines. I don't think they're very interesting. General overview of the job system. I don't like job systems. There's a little bit of a job system, but it's going to get taken out later. It's not a good way to do things. What are you doing instead of jobs? Regular multi-threading, the way you normally would. Any opinions on fibers? Not really. Not really. Is this going to be safe to run on processors other than x86? What do you mean by safe to run? Do you mean like if something has a weak memory model? Or do you mean like if something has a different endian? Like I don't know the question. How does the hot deploy? Why do you keep saying hot deploy? I don't know what that means. What are my thoughts on dealing with people who think I'm wasting time trying to invent things from scratch? Well, okay, there's two aspects to that. Because it depends on where you are in your career and experience level, right? If you are younger and you're doing things from scratch, it looks more like you're wasting time because you maybe don't get super good results, or maybe it's hard to finish things or whatever, or maybe the things you make are not clearly better than the old things. But the ingredient that people miss about that situation is that you are actually building skills that they are not when you do that, right? Many skills, both the skills to solve those kinds of technical problems and also the general like psychological bearing of not being afraid of low-level things or of not being afraid to have to make actual code that does a job as opposed to just glues things together, right? So those are all things you're working on when you're younger doing that. When you're older doing this kind of thing, Well, you really should have been able to get results of some kind or another by doing that. If you haven't, eventually, then maybe you aren't doing it right. You always have to entertain that possibility that maybe you really aren't doing it right. But if you are getting results, then you probably should be getting results better than the people who are saying that kind of stuff, right? So that's all. Guys, are you old at 87? Well, you're older than me. I'm not sure I believe that someone named X, capital X, the big fa, capital X, lowercase x is 87, though. That doesn't strike me as a name that an 87-year-old would pick. Maybe it is. Could it be possible to do your calculations with the queued in the batch? No, the batch is just an array of queues. That's all it is. It is not worth, you're making a big deal out of it. It's not worth it. It's just an array of queues. That's all it is. That's all it is. Is the compiler faster on Linux? I don't know. You would have to test on comparable hardware, which I don't. I don't have identical hardware setups. And even if it were like any speed differential right now, probably is not that meaningful because, we haven't, there's a lot of things that are not tuned. And when things are kind of sloppy, well, that could have different impacts in different places. Some people aren't as invested in becoming an engineer. Well, yes, that is clearly true. I feel that way when I read my Twitter responses all the time. You just have to see that for what it is. It's like, all right, I don't know why they think they don't have to be a good engineer, but then still think their opinions should matter as much as a good engineer's opinions. But that's the age that we live in, is the internet of garbage opinions, How long does it take to build debug version? Not that long. I mean, too long, right? Because it's in C++, but like it's under a minute. It's like 17 seconds or something. Let's see. Let's time it. Okay, wait. So we're going to cancel the build. We're going to clean. Going to get the stopwatch. And about 26 seconds, which is, of course, way too long, but it's not TensorFlow long. So, yeah, the LLVM file really takes a long time. It's really annoying. Yeah, it's like 50K lines. Let's see. 49280. Did I do any machine learning work? No. Okay. So we want to find received from interceptor. Let's not worry about that. Okay. So this is in interp. So instead of this, we want to go atomic, no. Does it, okay, let's first of all make sure that nobody uses async actions completed. Right? Oh. That's interesting. Not sure I like that. We'll put that in to do. So if those are each 32 bits, you could do a 64-bit interlock compare exchange to update them both atomically, just to be safe, which I'm not sure that's absolutely necessary, but it's the clean, minimal surprise thing to do. All right. So going back here, so we're going to go, instead of atomic, whoops, cannot type today. Instead of atomic decrement, we're going to atomic subtract from async actions running. Actually, no. Let's not do this. Let's. Okay, we're going to keep this simple. Well, I don't know which way is simpler, honestly. So now what I'm thinking is, we subtract the number of declarations that are coming out. But then add one for the message. Let's try that one. Okay. The number of QUDs. Okay, we're subtracting the number of QUDs that came in the batch. Add the number of decals that went out in this. Oh no, not the number of decals. Add 1 for the message batch sent to interceptors. We you know what? Here's another thing to do on the to-do. Add 1 for the message batch sent to interceptors. We only count 1 per batch there. We count multiple per batch here because batches don't stick together. Slightly confusing. Okay. So if we have any declarations to send out, then delta is 1 minus decals.items, right? Which will be 0 or less because we're only doing this if there's at least 1 declaration. And we're just going to go atomic add to async actions running delta. Boy, that's easy to screw up. Okay, so then that's 1/2 of this. But the other thing, when we pass this batch in, we need to change that counter as well. That happens. Can't find it. Grab and handle 1 batch. No, that's what we do. That comes out of, well, we can look for export batch mutex. It's both here. Okay, export batch. That's called externally. We pass an array of QUDs. We just make this. And here's where we increment this. Counting exports. Counting exports, we say atomic add this with okay. Chances are I just broke everything horribly. But let's go for a release build, because why? Why not? All right. Yeah, we broke it. Why am I outputting this? That's weird. That's a debugging. Wait, what? Oh. That's an internal debugging thing. Oh, this was to... Okay, this is weird. Because this is a bug that we get spuriously sometimes that I've been working on. And now we're getting it all over the place. But that might not be meaningful. So my assumption about what's going on would normally be that that like I screwed up this counter and it's going to 0 too early or something. However, it's very suspicious to me that all I am seeing here is operator overload errors. I'm not seeing any other kind of undeclared identifier. So maybe what actually just happened is that I cleaned up some things and exposed this bug more clearly. And now it's just totally happening all the time instead of happening rarely. I'm not sure why that would happen, but that might be what happened. And that would make me happy because it was bothering me that I didn't know what was going on here. Let's just let's make a note to take this out because we're actually probably shipping that in the beta accidentally. Okay. So that's kind of interesting. Is about to trigger a non-placeholder assertion. Okay, so before we go investigate this, let's just make sure something else isn't egregiously broken here. So for example, in our atomic so we have this atomic add. This is our default atomic add returns the old value. So we can just do this. Auto old value, assert old value plus delta is greater than or equal to 0, right? We should never decrement to a negative value. Let's just see if that assert goes off. It hopefully won't. But, you know, it might. It might. No. Well, we hit this thing without hitting that. Okay, so this is interesting, though. This is so the funny thing about this was we were getting this bug from the build machine frequently. And that's why I was adding more information. I was not ever able to reproduce this bug on my own machine. But now, for whatever reason, I am able to repro this bug on my machine because I changed something else, right? Which sort of leads me to believe maybe it's threading related. Maybe it's not. It actually could be that I goofed on this counter. And so now we're like starving it for messages, but maybe that just causes things to happen in a different order, but it's not a threading issue. So this is actually just interesting now. Aren't these two atomic operations on the counters? Not really. I mean, it doesn't. Yes, I put that in my notes if you were watching. I even mentioned it verbally, but I'm not that worried about it because if those were non-atomic, I don't think that what the code does in response will cause anything bad to happen. It's just cleaner to do them atomically, for sure. It's less, you don't have to explain to people why they're non-atomic, including people who come later to work on the code if you do them atomically, right? It's just they're not necessarily set up that way. I don't want to take the time to rat hole on that while I'm working on other things. Right? Okay, this is great, though. This has been bothering me for 3 weeks. It happens every time, right? Every frickin' time. So let's see. This might by itself be involved. Like, for all I know, this could be a several-hour thing to try to fix this. Let's just see. This is great. If all we even do on Superstream Sunday is fix this bug, even if we have to revert everything else, that's good. I mean, it's not as good as also doing other things, but it's good because this bug has been bothering us. Okay, so what's happening here, we're in this place called explain.cpp, which is where we go when the compiler can't build anymore, okay? The fact that it thinks it can't build anymore is bad. Now it may be what's it called? It may be because async action's running. It may be because I messed things up. Oh, what? What? So weird. Oh. We really need this to be greater than 0 because of this 1. Okay, that wasn't the problem. That means we never exported anything? This is really weird. Like, since that's the case, wait, what? Come on, bro. No, we did export things. Now I'm confused. Because we exported stuff, that's how this variable got set. I guess we exported everything we got, and then the messages came back in, and that's how it got down to 0. But we didn't ever reduce it to 0. So maybe that part is working correctly. Oh, maybe our, hold on. This is something I wrote last night that we want to do eventually. Once we start holding things back, then we want to put them forward here. But right now, we don't want to do that. Otherwise, we're sending duplicate things through messaging. Okay, so now we have a different issue. Okay, so that was the problem. Now we have a different problem where we're infinite looping because our thing isn't going down to 0. Yay. But it's interesting that this worked. This like correctly removed everybody who was ready. It's just, okay, one thing at a time. Let's put this bug back. Because, okay, so the fact that I could easily see how that being wrong could cause chaos here, but when this chaos happens, I want to at least fix this error message, because this assertion is because like we're confused, right? So I want to fix this confusion. And then once this error message is better, then we can go back and fix this to like do, maybe we'll just leave the, I don't know. We should re-comment that out though. I don't know, man. All right. Is it possible that you actually have two issues? One is this bug and another is something that causes the compiler to be stuck? Yes, that is possible. In fact, I would put the likelihood of that at least 50-50, that this placeholder assertion is not the real problem. This could just be something simple where I was just confused about what could be happening. And maybe I'll just go look at it and go, oh, this should be that, right? Now, if it was getting stuck, I did fix some data races yesterday that might address that. So, and in fact, we're fixing more today that could address that. So yeah, we'll see. I mean, you know, we're just fixing stuff. That's all. All right, so we're going to go to explain. see, all this stuff is stuff that I put in so that we would know where this is happening, because we were just hitting this assert on the build machine down here. All right. Well, let's just see. So this code is, it is saying okay, we have an identifier. It is not bound to something. But we are able to find a binding for it. That is weird. Except maybe not. I need to think about this. Okay, because operator overloads are kind of a complicated multi-step process that involves looking at multiple identifiers. So like, so now I have to dredge up from my memory how this whole operator overloading thing works. I just rewrote it in like December. And maybe explain just doesn't understand. Just like parents just don't understand. All right. So it's an identifier. And we got it from this. Okay. Yeah, this was pushed. It is at line 3518 of draw. So it is an actual plus. So it's actually not doing the complicated part of operator overloading. This check that we are doing is a little bit, I think, bogus. But this is not sleeping. This is weird. Okay, here's my theory about what's going on. My theory is the following. Let me explain some background. All right, so we have these queues that I've been talking about. And they go through the compilation pipeline. One of the most important stages of the compilation pipeline is type inference. It's also complicated. And that's where things like operator overloading happen, right? So when you say plus, it says, oh, that's a plus for a complex data type. Let me go make this new identifier. In fact, when it sees a plus, right, that's like a binary operator in the syntax tree, but it rewrites that. It says, let's make that into a function call for a thing called plus, and then with some arguments and so forth, right? So that's what happens. And to do that, it makes a new little, so first it constructs these expressions for this procedure call, and then it flattens these out into a new array of stuff that the compiler should iterate over and do type checking on. And it pushes that onto this little stack, sort of for this queue, these are the things that need to be inferred. So it says, basically, infer this procedure call, then come back to me, right? Now, if you push that thing, you actually have made progress in compilation, right? But I don't think we're actually telling the compiler when we do that we made progress, right? So it might be saying, like the most obvious way that the compiler could make progress is if it manages to completely do type inference on a new queued, right? That's usually how we make progress. But sometimes there are other ways of making progress, like, you know, a load completed and added new stuff to a namespace or whatever, right? So pushing this thing is progress. And if that happens, if you get a cycle when only these things happen, when only you push new stuff, you could get the compiler thinking it's stuck when it actually made progress. So I think the fix for that is not too bad. Like when we push a new thing, we just tell the infer pipe that we made progress in some way. And in theory, that'll keep this from happening. Now, I don't know why. The only thing that makes me suspicious about that explanation, that sounds like a thing that should be fixed no matter what. I want to check and make sure that what I said is just true, that we don't tell anyone that we made progress, because that would be a mistake. But yeah. I'm not sure. The only thing that's fishy is like, why is this so clean? And it wasn't clean before. Like I'm just not sure. Like, why is this other bug that we caused making this happen very cleanly? I don't really quite understand that. But I do sort of understand the actual problem. So let's look. So first, let's look at has made progress. Whoops. Which is a function that people call to say, hey, pipe, did you make progress? So if we broke cycles, like reference cycles, then yes. If we outputted things, etc., right? So we're going to say if pipe.num flattens added, return true. This only happens on the infer pipe, of course. All right, so okay, so now when we call push and flatten, that should increment this value. And this, we don't have to worry about multi-threading because this all happens synchronously right now. So like, oh, well, we do seem to have this. Oh. We were counting it. Already. Not quite in the same way. We didn't do it in a pipe progress way. Okay, well, never mind. Never mind. I will take a different tactic. Let's hit that bug again. So here we can just say, what is this identifier? It is this one. Let's make sure it's the same place. Looks like it. Yeah. So Go to resolve one ident and set a breakpoint here. And see if we ever even get there. If we don't, that's additional information. If we do, then we'll see why we don't manage to look anything up. Because the assertion that we're doing is saying, hey, we're claiming that we couldn't resolve this identifier, but when I go try to do it manually, we could. So why didn't you do it? Why'd you say we were stuck? So, well, we want to answer that question. Is this a multi-threading bug? I don't know. I don't think so. But I don't know. We don't really have a way to run the compiler completely without threads. That's just not a thing. We can run the compiler with one thread per workspace. But completely in one thread is not a thing that we can do. Visual Studio breakpoints take a long time. We eat almonds when Visual Studio takes a long time. But my queues are unbounded. Yep, sure. You want to do sport workout stuff to get healthy, but also write productive code. You're stuck. What should you do? Look, you just got to, if you actually want to do those things, you'll do those things. Yeah, it is often faster to hard code the if. I was hoping this one would be reasonably fast just because identifiers are a minority of the total expression types. So I was hoping that we would get to this faster, but nope. Nope. I will point out this has gotten slower over time. I don't know what their problem is. You're betting that breakpoints would be 100 times faster if they didn't force ASLR on people. Yeah, I mean, ASLR prevents you from doing some things that would be really good. Well, sort of. The thing is, once your program is multi-threaded, it starts being hard to be deterministic about memory addresses anyway. So, I don't know. I used to be very upset about ASLR. Now I'm only mildly upset about ASLR. Not very portable? Sure it is. Just ship different data sets for different CPUs. It's fine. That's what we do in games anyway. Or just remap it on the systems that you don't mind being slower. So there's been a lot of questions so far, especially I think because I haven't streamed in a while. There's been a lot of questions of the same questions people ask me all the time, and I'm just skipping them because I will go insane if I have to answer all these questions all the time. There should be a frequently asked questions, but there isn't. Sorry. Is the concept of making progress there to ensure the compiler doesn't try to resolve a dependency forever? Yes. So here's the deal. In this language, you could have a meta program or some other code that's just running at compile time, add more code to your program, right? So say you're trying to call some function f, and f doesn't exist yet. Well, at some point you need to stop and say, hey, there's an undeclared identifier f. When are you allowed to do that? That's what this is about, right? Like, well, okay, well, yeah. Like if somebody might still define f, you don't want to stop, but you do have to stop eventually. You have to stop when it's no longer possible for somebody to do that definition. Or really, I mean, it's not exactly when it's no longer possible, because you could have a troll metaprogram that like sleeps an arbitrary amount of time and then adds a thing. So we have additional constraints in place, like, well, I don't want to get into that whole explanation of how it works, but it's just, yeah, like you make a well-defined system for when things might still happen and when they might not happen anymore. All right. So we got some additional information here. We did not ever try to resolve our identifier. Which is weird. There are a couple reasons why that might happen, though. One might be if when we flatten this, we maybe added new dependencies that prevent this from being processed anymore. That could be annoying to search through by hand to look for. But instead, we can find the moment where this new flattened gets pushed. That's the point where this operator overload is expanding. And then we could like go forward from there to see why it doesn't get processed. So here, run expression 24 out of 97. That is a binary operator. It is this one. So we go to here. We go to here. Now I'm going to, again, do a breakpoint, then not compile it in because, like, we'll see what happens. Yeah. Whenever people say, what's wrong with Visual Studio? It's so great. It's like, guys, it has so many problems. You guess I'd not want a fact to be viewer made. Yeah, I don't know. I mean, maybe it would come out great. Maybe maybe I would be sad. You know, so. Well, that didn't take too long. Let me start heating up some tea, though. Okay. So we're going to end up in this routine that makes a procedure call and pushes it. So let's get there. Custom operator. We make a custom operator call. And then we go to push and flatten. Okay. As nearly as we could tell, this flattened never gets handled. And the question is why? Okay. We actually could have gone even faster on our breakpoint by setting it here. Because this happens in a, like, the last breakpoint that we put happens for all binary operators, but this one happens only for custom operators, which is a minority. Okay, so when this happens, we get here, and then, okay, so we've pushed and flattened, we return false, okay, and return false just says, come back later and do more work. We could actually try and do this work now, and I thought about that, but it was like, that's more complicated. All right, so first we're going to print this. This is a serial number for this queued. It's actually in a different space than this serial number. But anyway, that's the serial number for this queued. And I'm actually not sure why it's in a separate space anymore. There used to be a good reason for that, but now there isn't. Okay, this is the outer loop that just calls inferred types on this thing. Okay. So it's called it now, right? So really what I want to do is say, what happens? So we get thrown back. A throwback just says hey, you know, do this again next time around. So I just want to see what happens. Do we ever even get to this again? Or not? My suspicion is maybe not for some reason. We didn't. Okay, so that is really interesting. Like we literally never even tried to process that guy again. Oh, we skipped. Okay, that breakpoint skips the dependency analysis, though. So it might be for a quasi-legitimate reason. It might be just for no good reason. So the rules used to decide when to stop waiting for the definition are based on the structure of the asked. No, they're based on just the state of the whole compiler. Like you know, if some threads are working on stuff, new results are going to happen. So don't quit, right? If we manage to push things forward in the pipeline, new results are going to happen. So don't quit. There's just a number of conditions like that. You know, we've sent some messages to the metaprogram, and the metaprogram hasn't read them yet, or hasn't finished reading them. So new stuff might happen because the metaprogram might do things in response to those messages. So there's categories of things like that. I kind of want a hot drink and a cold drink, and I got to get rid of my old cold drink. Will there be another break after the stream? I don't know. I'm not in the mood to stream super a lot right now, so yeah. Would it help the debugging to simplify the test case? Maybe, but I'm not at the point where I'm being confused by the test case yet. We might get there where that's the right thing to do. Well, it might be the right thing to do now. We might get there to where I feel like that's the right thing to do next. So we have this queued. It is pushing its new procedure and it's never getting called back. And the question is, I could think of a couple of things that could happen. One, maybe it's adding a dependency, right? That could be a thing. Two, maybe there's just some kind of a bug in the pipe handling. Like the infer pipe is a pipe that multiple threads access and put things into. And so a thread bug could definitely result in data being totally messed up, but it's inside a mutex. But this is C++, where there's no way to know if somebody does random ass stuff not protected by a mutex. So could someone give me a decent answer to debugging on Linux? I mean, everybody always says the same things and they're all terrible. So yeah, it's fine. It is what it is. When would I recommend using that to inherit a struct? I don't know. I don't think you should really inherit a struct very often. I feel like I do it in a few small, simple use cases, and that's it. I don't know if there's a general rule for something like that. Your hunch is that it should be possible to model the compilation state so that the driver knows when a thread subprogram cannot possibly be the source of some definition. Yeah, I mean, that's kind of what I said, though. I'm not sure how what you're saying is different from what I'm explaining. Can I estimate how much the compiler is completed? No, I have no idea how to answer that question. But is not everything just terrible no matter what? Yeah, but there's different levels of terrible. So Visual Studio is pretty damn terrible. But I can at least use it to debug programs in an okay way. Like, as terrible as Visual Studio is, it is way better than trying to use GDB. Just in terms of raw productivity. So like, it makes me unhappy to use Visual Studio, but it's way better than GDB. Remedy doesn't have the data breakpoints in there yet, as last I checked, so I can't switch to it yet. It also doesn't run on Linux, so like I can't use it there. So, you know, everybody's doing a bad job, but some people are doing a much worse job than others. Supposedly Alan and Nick have the rad debugger going full stream. Oh, well, that'll be good. I mean, I don't know why Jeff didn't kick someone's ass into doing that like 5 years ago when he said he would, but like better late than never. How is Qt Creator? Like all of these things, everybody says, oh, I use this and it's great. And then you try to use it and it's terrible. And, you know, this is kind of dumb, but like, I have heuristics, all right? Any program named after the widget set it was made with is bad. All right? That is a heuristic that I just use. And it's not 100% foolproof, but it's mostly foolproof, right? you have to use a thing for quite a while before you can say if it's bad? Not really. Sometimes bad is evident in the first 5 minutes. Sometimes it's not. Sometimes things seem good. But, I think my problem is a lot of people just don't do much. And because they're not trying to do much, they're fine. They're like, oh, I use this thing and it takes me, 20 hours to debug a simple error. But that's fine because I don't do much. And I'm like, but I try to get work done. I want a debugger that helps you get work done. I think that's the difference. And the thing is, you don't know. Like, if all you've ever done is use GDB your whole life, you don't know how bad it is. Part of why it's not out yet is they were mostly doing one platform, and now they're getting the process control stuff for other platforms. Well, I look forward to seeing what it looks like. I mean, to be fair, I've seen some kind of not that good stuff come out of RAD on 1 or 2 occasions, so I'm not sure how this is going to be, but I hope it'll be good. So I would love to switch off Visual Studio, dude. I would do it so fast. Problem with GDB is it's actually got all the features. So when you try to explain to someone why it sucks, you have to explain usability things, which aren't as easy to express. Oh, I know. Yeah. That's why I don't even try to explain that much, because I don't want to get into a big, long, drawn-out argument. And explaining usability to someone is hard because people think unusable things are usable if they haven't used better things, right? And so you can't really explain. They have to go use better things and then come back, right? It's like someone thinking that their horse and buggy in 1883 is really awesome. And you're like, dude, I just flew to Singapore and you're telling me about your horse and buggy that are awesome. And it's like the dude you try to explain what a jet is and he doesn't understand or doesn't believe you. So yeah. Does GDB actually correctly debug threaded programs now? Like, does it actually correctly report the states of all the threads and things, or does it still not do that? Will I work to create a better Visual Studio Debugger alternative? Not if RAD Debugger exists and it's good, then no. I mean, I have plenty of things to do, and some of them I do if nobody else is going to do them. But if somebody else is going to do a good job of something, then great. Great. It means I don't have to do it. Yeah, like the whole terrible thing about GDB is it's not a library. And so everyone makes all these things that are like, talk to it through a pipe because that's the Unix way. And it's the most terrible thing ever. And they're buggy and they desync and then resync behind your back. And like, it's so bad, dude. Should come up to Seattle and we can go get a demo. Maybe. Yeah, I haven't been to see. I could use some serious pie. You know what I'm saying? I could use some of the Whole Foods pizza that I like that I don't remember what it's called. Try Valgrind. Dude, I was trying Valgrind in 1990, okay? Like, why are people saying this stuff to me as though it's like a new, amazing whatever? Valgrind is bad. It's been bad. You can sometimes get useful information out of it. Yes, that is correct. Sometimes you can use Valgrind to get useful information. But literally, I used that frickin' program 30 years ago. I know how it works, okay? There are similar things on Windows. There's, shoot, what's the frickin' program that I used last time? I don't remember. Anyway, there are similar things on Windows. Dr. Memory, yes. In the new language, we're just, okay, well, interesting story. The reason why I'm doing this stuff today, fixing this race condition, is so I can go finish doing the compiler restructuring that I was trying to work on before this. And the reason I was doing that compiler restructuring is because there's a thing right now where it's a little bit ill-defined. There's this thing called the preload in the compiler, which is like the basic data structures that represent types and all that, like actually get compiled. And the reason that happens is so that you have type information for them the same way as everything else. Otherwise, they would be hard-coded into the compiler. But anyway, they get compiled before your user code gets compiled. And the thing is, when those get compiled right now, they're not affectable by options, by build options. And so I'm trying to shift that to later, and that was triggering a race condition or something, okay? But the point is, the reason I was trying to do that is so I could finish implementing a certain feature. And the reason I was trying to implement that feature is so that I could have actually good memory debugging built in to the code that we ship with the compiler that you can just use, right? And you don't have to use a stupid ass extra tool like Valgrind or Dr. Memory. It's just right there, right? Visual C++ actually has something like that in its C standard library. It's, however, bad and people don't use it very often. The point here is to make a good one. And so that'll be built into the, essentially built into the compiler. I mean, it's a hook between the compiler and the user level code, but it'll be fast and it'll give you good and useful data, etc. So that is what we're trying to do, is be able to easily find things like memory leaks and whatever. And we're like 4 levels down from that in the task. So can you walk me through what the bug is here? Okay. The general bug that is happening is the following. You know, I was running thread sanitizer on the Linux machine because I guess that would work on Clang on Windows. I'm not sure, and I didn't want to deal with the hassle of running Clang on Windows and the uncertainty involved there. And also, it's just good to run the compiler on Linux sometimes to make sure, especially because I'm giving it out to beta users who are using it on Linux, some of them. And so I should be using it on Linux sometimes just as a sanity check that it doesn't like explode, right? So I was doing that and I was fixing some race conditions. Most of them were pretty trivial, but a couple of them were kind of serious, okay? One that was kind of serious is as follows. You know, there's this compilation pipeline that everything goes through. It gets parsed, it gets type checked. It goes through a messaging system that tells your metaprogram about the syntax tree of your stuff, right? And that happens after type checking because that way your metaprogram gets all this type information, which is very useful, right? So it goes through messaging, comes back from messaging when your metaprogram is done handling the message. And then from there, it probably goes on in the pipeline, but it actually could go backwards if you decide to use that opportunity to modify a procedure, right? Then it can go back through type checking, right? But if it doesn't do that, it'll continue through bytecode generation and then machine code generation. And I skipped a couple of minor stages, but that's the basic thing. Okay. So now the thing is, these things come in these little packages called queues, which are, what this is, for example, right? And a queued is sort of everything that's convenient for the compiler to package together in one piece, right? And so, for example, like a body of a procedure all goes in one queued, right? Because it just acts as a unit. Like, if you're working on type checking the body of the procedure, that's fine. But once the whole thing is type checked, it's very easy to think about as like, okay, the body of this procedure is at a certain stage of compilation, right? Okay. So what happens is you pass one of these queues to the messaging system. The queued has a root expression, and then you kind of recurse down the syntax tree and like look at all the nodes, and you make exported versions of all those nodes in a parallel set of data structures that lives in user land. And the reason those are different data structures is so that there's API stability between, meta programs and the main program, right? So we're basically copying these structures into a parallel set of structures that users can use. Now, that used to be a dumb recursive thing because I wrote this code way back when nothing was threaded, right? The problem is sometimes something in your queued will point at something in another queued. It's not that common, but it does happen sometimes. It's legitimate to do that. And the problem is, if you do this dumb recursion, you start crossing into that other queued and exporting its stuff. And the problem is, it might be in an earlier stage of compilation, for example, in type checking, so that stuff may be getting changed. And that is bad, right? And so what I started doing last night and then continued today on stream is write a system where we check for that happening and say, oh, we can't cross this boundary, right? So if we need to cross the boundary, well, if the result is ready, then fine, the result's ready, just use it. Otherwise, defer this guy until later, right? So we're in the middle of doing that, but then in the process of doing that, we triggered some other bug that was a weird, spurious bug that involves thinking that some identifiers, maybe only operator overloads, but maybe identifiers generally are not defined when they are. And I started looking into that. And that might be a data race, but I feel like it's not. I feel like it's something more basic. So that's the thread of what is generally happening, if that makes any sense at all. Does it happen when you run single threaded? The data race in exporting, no. So there's no such thing as being able to run completely single threaded. The reason is, so what you can do is you can run like basically one thread per workspace, where a workspace, like there's separate workspaces that can live in the compiler at once, because if you're making a meta program and the meta program is compiling another program, you want those to be isolated from each other. And not only are they isolated from each other, but like your meta program has control flow, and like that's just represented by your meta program just running as a thread. So right now you can't ever turn those off. I used to have a way of sort of trying to turn those off, and it wasn't good, right? But within any particular program, yes, you can turn it to run single threaded. And in that case, this would not be a race condition. Does this other thing happen in that case? Well, I don't know, because here's the weird thing is we had this bug a little bit before, and like it was a spurious thing that would happen, but like only on the build machine. I could never get it to happen. you know, I switched to Linux for a while. I couldn't get it to happen there either, but like the build machine had this, it was one of those magical Heisenbugs, right? And so I've just started looking into it because now it's happening 100% of the time. And I just want to know like what's happening. I'm not even sure if the bug is that the diagnostic is wrong or that it's actually a bug and all this stuff. And so it's the problem is we've recursed from one issue into another issue. And I don't want to brush this one aside because it was like a Heisenbug. And so if it's a serious problem as opposed to the diagnostic being bad, well, it is, I guess it is a serious problem. Anyway, so I've just started looking into this one and then just was answering questions and stuff. So we don't know that much about what's exactly going on here yet. Yeah. But basically what this looks like is, you know, we think an identifier is undeclared, but it's not. And so the compiler thinks it's stuck and can't compile anymore, but it really should be able to, because we get here into this thing where we're trying to explain to the user what the problem is. And we're like, wait, why didn't we look up this identifier? Because we can do it now. And so that might be a threaded issue. Like maybe a thread made it possible to look up the identifier and we like didn't trigger some event telling us that that happened. Or maybe there's just some other bug. And it looks like maybe there's just some other bug. But maybe not. Maybe the diagnostic code is wrong. Maybe we shouldn't be here without checking all the frickin' dependencies. So we need to just dig further into this and figure it out. And to help us do that will be the turkey jerky. One thing you often do with this sort of stuff for extra information is stick the RDTSC of the last person who updated something into the data structure. Yeah, that wouldn't be a bad idea. Part of the problem here, so the next thing I'm going to look into is whether a dependency got added that is preventing this thing from going back through type checking. That seems to me like the most likely thing. The thing is that whole dependency system I want to get rid of because it's kind of undebuggable and annoying and error prone. And I've been gradually getting rid of it for like years, but it still sticks around because it's not that easy to get rid of the last vestiges of it. So yeah, he's probably talking about Jelly No Puzzle. So Tim has probably very different views about how to program than me. I mean, he wrote the Unreal Engine, which is very object-oriented. And it's easy for me to look at something like the Unreal Engine and say, wow, I don't really like it when my code looks like that. But he probably looks at it and thinks things like, this structure helped our customers successfully ship a lot of games that sold billions of dollars, right? And also we're using it to do all this Fortnite stuff right now, right? And so I certainly understand him having a different viewpoint on this than me. But it is very different. his point was more about C++ and Rust are slow. Yes, and they are, admittedly. And Tim has a little bit of a point, right? Which is, if you have generics, there is this combinatoric explosion that happens. But again, my answer to that is A, if your compiler is really fast, if your compiler is 1,000 times faster than a C++ compiler, it's just not that big of a deal. And then B, that is always a place where programmer discipline comes into play, right? If your code looks like a boost or eigen or whatever, it's going to be terrible, yes. Just don't do that. Like, there's not good reasons to do that, right? And I think Tim, especially from his later alien knowledge style comment, kind of wants to go into that super mathematical place where everything is like, you know, maybe eigen or boosty. I don't want to go there because I find that stuff, regardless of implementation details, I just find it too hard to think about. I want to know what a vector 3 is, right? I don't want an abstract vector in a space defined by blah, 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 with dimensions defined by blah, 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 etc. No, I want a vector 3, okay? So like, both in terms of just reasoning about the program and in terms of knowing what code that turns into. And so I disagree with Tim on that very fundamentally. We'll see though. I mean, I'm interested in people following new directions. So I'm interested to see what he does, but like I would not do that stuff. Do I think there is a way to go super mathematical without turning into eigen or whatever? I don't know. There might be. Did I watch the TensorFlow stream? I tried to. But I tried to watch it from a Linux laptop, and so the answer is no, I didn't see most of it. I somehow managed to see some of it at the end. Why, I'm not sure. Something just magically installed, and then I could see it. But I couldn't see most of it. No. Despite trying 3 different things. Yeah, the Westlake Whole Foods had, I forget what the name of it is, but one of their pizzas is really good. Or it used to be really good, but last time I got it, went there, it wasn't that good. So I don't know. What exactly would super mathematical be? Yeah, when I say that, I mean going super eigenfunct or monoid land, right? How do I plan to cultivate the developer ecosystem? I hate the word ecosystem when applied to... See, these kinds of questions involve the problem, all right? If I sit down and start programming, I don't want to have to deal with an ecosystem. It's nice if there's things out there later that I could find that'll help me, but like... Ecosystem in reality means here's a bunch of problems you have to deal with before you can get work done. That's what that word actually means. And no, I don't want to give people a bunch of problems they have to deal with before they can get work done. I just want to give them a compiler that just works. That's the plan. Am I sure I don't want to give people problems? They deserve it? Well, definitely my Twitter audience and to some degree chat deserves problems, yes, but I don't want to be complicit in that. I said to some degree. I didn't say everybody in chat is guilty, just to some degree. Yeah, well, anyway, I don't want to put words in Tim Sweeney's mouth about what he's thinking. He's perfectly capable of saying what he's thinking. So that's just my interpretation of what he's saying and how I respond to it. But the point that I wanted to get to was, again, if your compiler is way faster, you can do a lot more and it's fast, right? So like saying that generics themselves is the problem because compilers are slow is sort of conflating two things, right? But then B, again, programmer restraint should be assumed, all right? People could write all sorts of bad code and often do and get very like not reality based about what they type in. And will explain to you all day about why that thing is supposed to be good or whatever, right? But it's not. And so if you're going to do that, if you're going to abuse your programming language that way, then yeah, the result will be bad. So, but don't do that, right? Don't do that. If you're like building a bridge, you build it out of the right material for the bridge you're building. You don't like keep piling crap on top of it and then get mad when it falls down or when people can't drive across it because there's too much crap on it, right? It's like the fault of the dude who built the bridge. That's what I'm trying to say there. So like, I don't think that what he was talking about is in reality a problem if you are a pragmatic person whose goal is to get work done. But you know, it's fine if he disagrees with me. Like that's totally cool. I'm interested to see what he does. The Romans used to make engineers live under the bridges for a year. Is that true? Because that's a really good idea. That is the way to make sure people have skin in the game. The problem is that doesn't really work with like Linux and stuff because the consequences just aren't bad enough. Like the consequence is that you have a mediocre life if you program on that system. But like people who are in the middle of a mediocre life don't notice because it's a very slow change kind of a thing, you know? It's like a boiling a frog kind of situation. Find it odd to blame compile time on generics because if you didn't have them, you would write multiple versions of that code for different types manually. Yeah, I mean, I also find it odd to think that delaying that to runtime is going to be faster somehow. Like he seemed to think that like, oh, we'll do like, you know, whatever you call it. Stuff like what Go already does with interfaces. What if we made the boiling frogs live under the bridge they built? Dude, if you can get boiling frogs to build a bridge, I will buy a ticket to that show. All right? You could make money just selling those tickets. If you write the multiple versions, it compiles faster, though. But why? Like, why does it compile faster? Isn't that just your compiler being broken? I mean, maybe it takes a little bit longer to instantiate a generic, but should it take that long? Like, should it take noticeably long? I don't feel like it should. Okay, let's get back to actually doing some work. So when does Handmade Hero start at 12? That'll be a good time for me to take a break. So at 12, we will raid Handmade Hero. And then maybe we'll come back later on Super Stream Sunday. So we're in explain, and we found that for some reason, okay, let's turn off this thing, which no, this is the one we wanted. We want to turn off this thing. This is this identifier lookup that never happens. So we're going to rerun. We're going to go to our binary operator custom procedure call expansion right here. See, like, look at this. There's not, I mean, this is more object-oriented than I would do it today a little bit. I mean, there's no inheritance here, but it's like in a class. But aside from that, like, it's just not hard to understand what's going on here, right? Whereas if you like eigenboost this up, you would have no idea what was going on. And it would take 20 times as long to compile. But of course, the modern C++ people will get mad at me for using pointers, because pointers are dangerous and scary. Programmers are supposed to be afraid of pointers. But they're also supposed to somehow write exception-safe code everywhere, which nobody is capable of doing. Okay, so we've got our custom operator call. Okay, this is not the right place to break, I don't think. What we actually want to do is we want to break further up. Because the thing is, if we're looking for a dependency, actually no, this is fine. Instead of theorizing that a dependency got added, which may or may not have happened even before that breakpoint, we're just going to set a breakpoint when we're pumping the pipe, okay, so there's this I don't know where it is. Let's go up to the top, search for pump pipe. All right, so here we go through, and for everything in the input, we check the dependencies. So here, this might be a slow breakpoint, but I want to know, do we ever see this guy again or not? Right? If we don't ever see this guy again, oh, we do. Okay. Okay. So, dependency cursor is 0. I guess we did add a dependency, because why else would this... Wait, what? Hold on. Why would it reset to 0 anyway? That's... I haven't thought about... Okay, this is the infer pipe. There's no surprise there. Dependency. These flags I need to clean out because I think some of these are unnecessary now. Okay. So whatever. This is going to go this way for a while because there's like 21 dependencies, but I'm not sure if I should just step through it or maybe just set breakpoints in the relevant. Problem is if I miss a breakpoint and it uses that one, then I'm sad. Okay, and if we get down to here, if we get down to there, actually I could have just set a, oh, I don't know, let's see. Okay. There is a dependency, and this must be new. So weird. Okay. So we have something, we're waiting on it to pass the size pipe. That's going to mean it's a struct probably, right? It's a struct. It's at line 600 of entities. It's a guy. Why are we waiting for struct guy? Probably because okay. So I'm starting to come to a conclusion about this. And the conclusion is there's sort of two problems happening. One is our diagnostic is a little bit wrong. The thing that says, hey, I can look up this identifier, but why not? And the thing is, it's like, okay, the identifier is not actually what we're stuck on. And in fact, I had enough information to see this. Let's just run all the way to the endpoint. The problem is because we have this old dependency system and then we have new things and all that, it gets a little bit hard to think about like what's going on sometimes. So here we can see this guy's called it right now. So like we look at it and the dependency cursor should be, yeah, it's still 11. So that thing that we just looked at, that struct guy, this thing is still waiting on. why is this waiting on struct guy? Well, this is not the plus operator. It's the thing that contains the plus operator. This is some procedure, right? So what this is saying is we're stuck on struct guy. The problem is our identifier reporter doesn't seem to care, because I don't know whether this is my fault or somebody added some code or whether I deleted some code, but like we've got this yielded on expression and we check this flattened thing. See, what's going on is this says if we started flattening, that means we got through our dependencies. And it's like, yeah, but actually we added more dependencies. So this is kind of a bug. I guess that's something Abner added, or maybe it was something that I added originally and then he just added this or something. But this is not really right. This needs to check that we're through our dependencies. So in theory, if I just fix this, then like we still won't successfully compile, but that might be because the bug is a different thing. And maybe we'll just get a circular dependency error or something instead of an undeclared identifier error. And that'll be better because it's more reflective of the actual problem. If anyone understands any of that. Handmade Hero is live. Well, now that I've explained the problem, maybe that's a good time to break. And maybe we'll host Casey. Let me verify experimentally that Handmade Hero is live. All right, we're going to kick you over to Casey for Superstream Sunday. Continuing. And we'll probably be back later today. We'll see. Thanks, everybody, for coming by. We didn't do too much real work. We did some, though. And that's better than we've done on stream in a while. So see you later. Do 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 do.